So the last quantity we are going to talk about is temperature. And temperature is a tricky one to define, and we need to get a little bit of intuition to really understand that. So for now we are going to take an operational definition, and we're going to say something very simple. Temperature is what you measure with a thermometer. And you would say, well, that doesn't tell me anything, right? That doesn't define temperature. Well, yes and no. It's not a conceptual definition. It is an operational definition. What you can do with this is go on to measure things. And this definition is based on a very important property. If you take two objects, right? So one has a temperature T1 initially, right? And then the other has a temperature T2, right? And then you bring them together, right? So you put them in contact, then they are going to reach the same temperature. So that is actually, this is an important property that is going to serve for a lot of the conceptual ideas that we're going to try to study. And so this is the equilibrium condition, and that's what we use to define temperature, right? So temperature is what you measure with a thermometer. So take a thermometer, you put it in contact with what you want to measure, and then you get a measuring that. So two things that are important is, well, your thermometer has to be small compared to whatever you want to measure, right? So by that we mean the temperature of what you're measuring shouldn't be affected by your thermometer. So there are units to measure the temperature. So the common one in the US is the Fahrenheit. There's also Celsius, and there is also Rankine, and there is the Kelvin. For this class, we're probably going to use Kelvin for much of the calculations, but in some cases we are going to use Celsius and Fahrenheit. So now let's look at, I lost my mouse, just a minute. So let's look at how to convert from one type of unit to the other. So the important one, let's start with Celsius and Kelvin, right? So the temperature in Kelvin is going to be equal to the temperature in Celsius plus 273. So that's the equation. That's all you need to know. It's the same scale, it's just shifted, right? It has a different origin. So now Celsius and Fahrenheit. So the temperature in Fahrenheit is equal to 9/5, the temperature in Celsius plus 32. So this is how you convert from one to the other. You can invert equations if you need to go the other way. And so on these equations, you don't need to remember. They'll be given to you in the equation sheet. Some important temperatures that are good to know. There is an absolute zero. Absolute zero. And so this is the lowest temperature we can ever reach. And in Celsius, it is minus 273. In Kelvin, it is just 0. And in Fahrenheit, it is minus 460. Another important point is the freezing point of water. And there is two E's here. Point of water. And then for this, so we get in Celsius, this is 0. In Kelvin, this is 273. And in Fahrenheit, this is 32. Room temperature is another important one. And these are numbers that you don't need to memorize, but you need to have an intuition about that. So roughly this is 37 for Celsius. It is 300 in Kelvin, or 310 in Kelvin, and 99 in degree Fahrenheit. Finally, boiling point of water. So boiling point of water, well, that would be 100 in Celsius, and you can see these are the two quantities that are used to define the Celsius scale. Then you have 293, I got that wrong, 373 Kelvin, and 212 Fahrenheit. So those are temperatures that you need to remember. So there's one more, which is the body temperature. The body temperature is close to room temperature, right? And actually, I think I made a mistake here. This is body temperature. So body temperature and room temperature was 20 degrees. Sorry about that. So this is 20, and this is 293, and this is 60. Yeah, so that is more. So those are values of temperatures that are used to, it's good that you have an intuition about those. It helps when you're solving problems. So how do we know that there's an absolute zero, that there are no negative Kelvin temperatures, right? That there is a minimum temperature? Well, I'm going to give you, I'm going to show you a simulation that is going to give you an intuition about that. And later on, we are going to look at that in more detail. So, so here we have a simulation. This is an ideal gas, and it has a temperature, right? So it has a temperature, some value here, right? And what you can see is that these atoms are moving really fast. So now I'm going to start cooling this down, and then you're going to see what happens. As I cool this down, then they are moving slower now, and then I can keep cooling this, and they move slower, and slower, and slower. And now they move very slow, and I can go to the minimum that I can have here, and then they move slower. The simulation doesn't allow me to do that, but I could even try to go slower than this, and then eventually I'm going to get to a point where these particles are not moving. At that point where they are not moving, that's when we say we have zero temperature. So temperature, from this, you can start guessing that is going to be related to the temperature is going to be to the speed of particles. And we are going to see later that more accurately, temperature is going to be proportional to the kinetic energy of each particle, which is 1/2. So that's how we're going to define temperature. Okay, so these are the main ideas for this week. Let's stop here. And then next week we are going to start looking into the ideal gas equation and how to study ideal gas.